Okay, guys, some day two SOPATO here. We're going to talk about a few things that we didn't get to in the lesson from Friday. Okay, so um, let's start with this. Here are some more trig functions that they could ask you to just give them the value of. So we're going to start with these three. They're really just inverses of other trig functions, so we're going to get that together. Okay, so this is going to be your recall side. Okay, recall that sine is equal to opposite over hypotenuse. Okay, well the inverse of sine is called or labeled as cosecant. Okay, this is cosecant. Cosecant is the inverse of sine, so cosecant is hypotenuse over opposite. Okay, again, recall that cosine is adjacent over hypotenuse. Well, its inverse is called secant, which is labeled as this. So the inverse, again, inverse means reciprocate the fraction. The inverse is hypotenuse over adjacent. And then the easiest one to remember, let's recall that tangent, or tan, was opposite over adjacent. Okay, so its inverse, very simply known as cotangent, or COT, that's equal to adjacent over opposite. Okay, so they could again give you any right triangle here. They could give you some side lengths and call this A, B, and C. Okay, and I might ask you for the secant of A. Okay, well here's how I remember these. I always remember that, hey, it'd be awful nice if cosecant was the inverse of cotangent. That would make sense, okay, but it's not. Sine is the inverse of cosecant. Cosine is the inverse of secant. So the cos never go together. Cosine never goes with cosecant. That's how I remember. The cos don't go together. Okay? So the secant, that's the inverse of cosine. Cosine is usually adjacent over hypotenuse, but we are going to flip or inverse that. So secant is hypotenuse 5 over adjacent, which is 3. Okay, we'll just do one more. I think you can pick up on this. The cosecant of A, that's the inverse of sine, opposite over hypotenuse. But now we are just going to do hypotenuse over opposite. And finally, the cotangent there of angle A would be now adjacent over opposite, which would be 3 over 4. Okay, so just some new trig functions in general. All right, now, the next thing is angles of elevation and depression. Okay, in general, what they're going to do is they're going to give you, these are going to be word problems, okay, where they talk about lines of sight and angles that are formed with lines of sight, and then give you, you're going to have to solve for what's missing, okay? So let's summarize a word problem here and get this on the same page. Okay, there's an airplane. Whose angle of descent is 3 degrees. Okay? If it starts at 5,000 feet, what's the straight line distance to the airport? So first of all, I would always encourage you to draw a picture, okay? Let's call this dot the plane. Okay? It's 5,000 feet, so straight down, it's it's 5,000 feet. Okay, and they want to know the distance that it is to the airport. Okay, let's put the airport over here. This is a triangle. Now, they said that this is the straight line distance. This is what we want to find. If they wanted this, we'll put it in a dashed line. If they wanted this, they would say the ground distance, they might call this. Okay, they were going to word these things in different ways, but it's 5,000 feet up, and the straight line distance is what we're finding. Now, what angle do we know? Okay, angles of elevation and angles of depression are always made with your horizontal line of sight. Okay, horizontal line of sight. Sorry, I gotta put my laptop down. That's about. Okay, so you got to think about where is the person or the object at, and you're going to make an angle with that horizontal line of sight. So the plane, okay, the plane is up here. Its horizontal line of sight, again, draw a horizontal line. The angle is formed with its horizontal line of sight. So the angle of depression is this angle. It's not even inside of my triangle, okay? But we can use it to find this angle that's inside of my triangle. So the angle of depression is always the horizontal line of sight and going down, okay? So this whole thing right here would be a 90-degree angle. 3 degrees of it are here, so this means that 87 degrees of it are here. Okay? So now I just have to ask myself, okay, what two sides do I have in comparison to this 87-degree angle? I have adjacent and hypotenuse. That's ka. Okay, so I want the cosine of the 87-degree angle is equal to adjacent, 5,000, over hypotenuse, which is x. I can't solve for x as long as it's on the bottom. So I've got x times the cosine of 87 equals 5,000. And now I just divide by the cosine of 87. And I get that x equals, well, let's type that in here. 5,000 divided by the cosine, cosine of 87. Let's make sure that I am in degrees. Let's make sure that I'm in degrees. I am. 5,000 divided by the cosine of 87. That's ready to go. Equals 95,536.61 feet. Okay, that's an angle of depression problem. Now, let's make an angle of elevation problem. Okay, we'll paraphrase a problem here. Let's see. You stand 150 feet from the base of the school. Okay. The angle of elevation to the top of the school is 11 degrees. How tall is the school? No, I just made this up, so I don't know if these numbers are realistic, but okay, here we go. Let's draw a picture. Here's me. Okay. I'm 150 feet from the base of the school. All right, and my angle of elevation, again, it goes in my horizontal line of sight. So you got to, and the only thing is you got to act like your eyes are actually on the ground for 1 second, okay? All right, so we're coming up like this. The angle of elevation is inside this triangle at 11 degrees. So angle of elevation goes up, it's inside the triangle. Angle of depression goes down, it's outside the triangle, okay? And I want to know how tall is the school. I want this. Make sure you draw a picture so you understand these things. Okay, so I've got opposite and adjacent. That's tangent. So the tan of 11 degrees is going to be opposite over adjacent. So all I got to do now is multiply by 150. And I get that 150 times the tan of 11 degrees is equal to x. Let's figure out what that is. 150 times the tangent of 11 degrees. In this case, the school would only be 29 feet tall. So that's not exactly realistic. 29.16 feet. Okay. All right, so that's angle of elevation and depression. Last day on this, and then we'll be moving on to another topic.